Alright, so I think I'm recording. Let's take a look at this problem number 4. We're given a relation that this y is equal to x divided by the quantity x squared minus 25, and I'm asked to find the domain and range. Whenever I'm given an equation and I'm asked to find the domain, I start out the exact same way every time. So I jokingly said that this was tattooed on my left shoulder. Don't go out and get a tattoo. It's just a joke. All right. So the domain is a set of all real numbers, excluding any values that cause division by zero. I do have a variable in the denominator. I am concerned about division by zero. But on the next one, any values of x that cause us to take an even root of a negative number, I do not have any variables that are underneath an even root. So I don't have to, I do not have to worry. Where did it go? Where did number 3 go? What did I do? There it is. Somehow I deleted it. Alright, so I don't have to worry about the second one, but I am concerned that I have a variable in the denominator. So, is it possible that there's some value of x that would cause x squared minus 25 to equal 0? Well, yeah. Okay, let's factor this, because generally it's easier to see in factored form. And when we have a trinomial, we also factor it. People ask me today, could you add 25 and take the square root of both sides? And you can, as long as you put the plus or minus in front of your radical, because we get answers of -5 and +5 as two solutions to this equation, and they're the only solutions to this equation. So those are the only values that I'm going to exclude from the domain. Every other value is okay. If you plug in some number that's different than -5, that's also different than +5, you'll get a related y value through this equation. So on my number line, until you get used to writing this answer in interval notation, I suggest that you make a quick little sketch. You're excluding -5 and +5, but every other number, all of the other numbers on the number line, are not solutions to this equation. They do not cause division by zero, so they are in the domain. If you plug any one of these numbers in that's in the shaded region, do this arithmetic, and you'll get a related y value. My domain, well, I've got this arrow shaded. I have this arrow shaded. So on the left here, this interval is from -infinity to -5. And then I'm excluding -5. So I need a union. If you're between -5 and +5, all of those numbers, well, I'm excluding +5, so I need a union. And if you're bigger than 5, all the way out to infinity. So there's my domain. Now, to figure out the range, I need to look at the graph. This is especially hard because I don't have a standard parent function to identify, to think of transformations to the right, to the left, up, down. So I'm just flat out going to have to go and look and see what it is and hopefully identify what the y values are from the picture of the graph. So let's go find, I've keyed these in ahead of time, some of them anyway. Alright. So yeah, so for problem 4, I have x divided by this x squared minus 25. So let's take a look at it. Alright. So we saw at -5 and +5 there was no y value to relate this that x could be related to, that -5 and +5 are not related to any y value. Alright, so let's go and look at this. Well, remember, if you're in a set, you don't have to list the values twice. Once you're in, you're in. So even though this is a pretty complicated graph, I can get away with focusing my attention on this part, that on this middle part, that is, let's change colors. That's going up here, and it's coming down, and it's going through the origin, so it has a y value of 0, and it's continuing here to go all the way down. So from negative infinity, if I go up through the graph all the way to positive infinity, that's my range. All of these y values are just repeated because they're shown over here. So my range is all real numbers from negative infinity to positive infinity, and I get that from just this middle portion of the graph. Yes, the graph has values over here that's from negative infinity up to y equals 0, and the graph is not touching the x-axis. So you're like, well, wait a minute, before when it didn't touch the x-axis, well, y equals 0 was excluded from the range, but look at the middle part. It went right through the origin right there, and at the origin, that point is 0, 0. So I know if you plug in 0, 0 is related to 0, because when you have 0 divided by negative 25, if I let x be 0, then it's okay to have a 0 in the numerator. That reduces to 0. It's not okay to have a 0 in the denominator. So anyway, I hope that helps with problem 4.